Hi all, a warm greeting to all the listeners of this session. Here is a video on searching in data structures, and this part of video includes linear search followed by binary search. So before we move on to linear search, we need to know the need for searching in data structures. Given a set of data, that is a collection of data, and you have to locate a specific element from the given collection of huge volume of data, we need an efficient searching algorithm to retrieve the data more effectively as well as efficiently. That is, you need to retrieve the data more correctly, that is nothing but effective, and the search cost should be minimum, that is nothing but an efficient searching algorithm. So when it comes to types of searching in data structures, basically we have two different types of searching in data structures. One is linear search and then the next one is binary search. So this video includes a section on linear search, and the next part of the video will include the content on binary search. As the name indicates, linear search, the alternate name for linear search is a sequential search. That is, the data is searched one by one, that is one after the other, given an array of n elements. In terms of C programming language or whatever programming language, when it comes to an array, the index starts with 0 and ends with n minus 1 given n data set. So in the given example, in the given slide, there are two different types of examples. One is with the animation, another one is with the normal image. So the first animated image explains with given n equal to 10 elements. So the value starts with 10 and it ends with 44. The given target value is 33 to be searched. So it starts with the index 0 and it concludes with n minus 1 if the data is not formed. If the data is formed, then it has to terminate with the index where 33 is being located. So starting with the index 0 with the value 10, it is compared with the target value 33. So whether 10 is equal to 33, not, and hence the iteration starts with the next, it moves on to the next element in the array, and then 14 is compared with 33, still it is not equal, and then it moves on with the next value 19, 26, 27, 31 and 33, and now the iteration stops because now 33 is equal to 33 and hence the index where 33 is located has been written. And it comes to the next example, given an array of n elements, that is n equal to 9, it ranges from 0 to 8 index. So you have to find the value 20 which is located at the index 6. So starting with 0th index, it has to iterate through the index 8 and it has to stop if the element is being formed. So starting with the index 0, naming the array as A. So array of 0, A of 0, I am just checking with 20. If it is equal, then I have to return that index 0. If not, I have to index by 1. So starting with the index 0, I am comparing array of 0, that is 10 is equal to 20. It is not equal, and then I am incrementing this I by 1, that is the iteration variable by 1, and now the iteration variable will be 1, and now array of 1 is 50. So whether 50 is equal to 20? No. Now again the same process gets repeated. I have to increment the iteration variable by 1. Now the index value will be 2, and then I have to compare that array of, that is A of 2 is 30, whether 30 is equal to 20? No. Again the same process. Incrementing the iteration variable and then comparing equal to 20 is equal to 20. Once the element is located at the index 6, the index 6 will be returned. If the element is not found in the array, then we have to return minus 1. So here is a test case, two different tests. In the first test cases, it includes 6 values and the target value 77 has to be found, which is located at the index 0. Because the value 5 is located at the index 0, 34 at the index 1, 65 at the index 2, and then 12 at the index 3, 77 at the index 4, given 6 data sets. And then second test case includes 8 values and the target value to be found is 200, which is not found at all because it starts with the index 0 with the value 101. 101 is compared with 200, it is not found, and then it is incremented. Iteration is incremented to the next index. The value is 392, it is compared with 200, still it is not found, and then incremented by 1. Iteration variable is incremented by 1 and the value is 1. 1 is compared with 200, still it is not equal. Now moving on to 54, still it is not equal till the value 93. It is compared and the iteration gest overcome completely, and hence the final result will be -1, stating that the target value 200 is not found in the given set of values. So here is a pseudocode. And the linear search. We are passing a list of items and the target value to be found. Second parameter is the target value to be found, and first one is a list of elements where you have to make a search. So you have to make iteration starting with the element, that is first element to the nth element. You have to make the iteration in the list. So for each item in the list, you have to check whether the target value is equal to the element in the list. If it is equal, then you have to return the element's location. If not, then you have to return -1. So here is a C programming code example. Given an array of n elements, the first parameter is an array of type integer. And then second parameter, it includes n number of elements in the array. The third parameter is the target value, that is the key to be searched for. So as I said before, the index starts with 0 and ends with n-1 because the array starts with 0 and ends with n-1 index for n number of values. So incrementing by sequence of 1, that is I plus plus. Here the iteration variable I have used is I. So array name is A and the iteration variable is I. So A of 0 is double equal to whether it is equal to key. If the key value is equal to the element searched, then return the index sites, the element resides. The iteration goes on until the element is found. If for loop terminates with the end of the list, then it states that the element is not found in the list, and hence you have to return -1, stating the given key value is not found in the given array A with n number of elements. So when it comes to time complexity, you have three different cases. One is the best case, another one is the average case, and the last one is the worst case. So when we speak about best case, if the element search, if it is found first in the given array, then you have to mention it as order of 1, that is it took constant time. When it comes to average case, that is if the search takes place n by 2 times or somewhere in the middle of the array, still you cannot tell it as n by 2 times. So in the big O notation, you have to tell it in the upper bound. So it is mentioned it as big O of n. When it comes to the worst case, that is if the element is not found in the given array, or if it is found at found as the last element in the array, still elements, if there are 1000 elements, the 1000th element is the key value to be found, then items have been traversed. So our worst case running time will be order of n. So brushing with that, we started with what is the need for searching. So given a huge volume of data, you have to locate a particular element. You need efficient searching algorithms. You have two different types of algorithms. One is linear search and another one is binary search. Linear search, it has an alternate name of sequential search. As the name indicates, it searches the elements one after the other. So starting with the index 0 to n-1, you have to traverse and you have to compare the target value index in the array. So if it is equal, you have to return that item's location. If not, you have to return -1. That's it. So here is the three cases, time complexity cases. And thank you.